Yo, hello YouTube. This is my C++ Minecraft clone, and today we'll start with a summary of what happened in the previous streams, so that new viewers can understand what's happening without knowing the previous streams. So this will be for first-time viewers. And after the summary of what happened, we'll decide what we're going to do today. And at the end of the stream, we'll summarize what happened during this stream. Yo, what's up, Frost? What's up, what's up? Hello, guys. What's up? And so, let's first do the summary. So basically, we got the caves. Here are the caves. They don't look the best, but this is just the start. It's good enough. And here, this cave is pretty close to the ceiling. Look at it. And done. We're here in the cave. Also, we managed to add the player. Look at how we can move around, jump around. And here we can fall through the cave. And now we're in the cave. We're slowly but surely getting there. Slowly but surely. And what else for the summary? We have inventory, but it's creative mode inventory. And we have biomes. We have just the plains, the snow. We have the desert. I think we have water as well. And what else do we have? We have nether biome, but we cannot access it currently. We have icons in the GUI, but some of them are not the pixel art. Some of them should be like pixel art. And we have the clouds, but they are the image pixel art, and you cannot see at the further back. And what else? I think this is a good summary. And so, as you guys know, first-time viewers, those that are here early, will decide what we're going to do today. And so we'll bring out the notepad and write down ideas for what to do today. And one idea I can write it down like sounds. And here we can brainstorm a few ideas, and I'll make a poll, and chat will decide what we are going to focus on today. Yo, what's up? Hello, there's tornado working. You're gonna release public? No. He responded to this very hello, what's up? Hello. Survival. Oh yeah, we can also, we could have crafting. Question mark. What else? We could, this is what we're going to focus on today. Item drops. Yeah, item drops. We could have item drops. We could have snow, rain, day, night cycle. What else can we focus on today? What else can we focus on? Maybe the caves. Ores. We could focus on ores today. Ores. We could do ores for mining. And here we could also have the right hand item to hold something in the right hand. Hold in right hand. I may bring up chat here so you guys can see what everybody is typing, but I'll not be able to see it. What else? Ores. Caves. Okay, there's another idea. Nether. To have the nether. What else? Guys? I'm live on both. I should be live on both. Maybe mobs. Oh, day-night cycle. Visible player model. Oh yeah. Okay. 3D noise. 3D noise. 3D noise. Visible player. Visible player. That looks. Thank you. I like crafting or sounds. What about ores? I already wrote it. Mountain. Oh, mountain. Isn't this like 3D noise? Mountains? Isn't it like kind of 3D noise? Some more animations like block animation. We have block animations. Oh, TNT, you have redstone. Oh, pizza, what? Adding. Oh, yes, yet. What's up? Hillbar, if we're doing crafting, do you have something planned out for all of the UI stuff? UI will be easy. Weather. Oh, I need to ping this. I'll figure it out. Carpet. Snow. Third person. Stairs. Try to implement particles. Or more biomes. Okay. More biomes and particles. And let me pin this message. Pin message. Like this. Okay, guys. We got quite a few here. We have 12 options. That's good enough. So my idea right now, chat, is I want you guys to type the number you want implemented, and the numbers I see the most, I'll put them into a poll. I'll create a poll from the numbers I see in chat. Pop out chat. Here I'll create a poll. Start a poll. What to do? So I see a 2, 6, 8, 6. Okay, I see 7s. Okay, is this the meme? Is this just the meme? I see a 12. Okay, 12. I see a 12. What else? We have one more option we can put. We have one more option. 9. Do we have a 9 before the... Oh, we have an 8. Yeah, we have an 8. We have an 8 as well. 5. Yeah, okay, let's do an 8 here. Okay, I'm starting a poll. And sadly, it's just YouTube. Twitch, you can just... If Twitch wants to interact, just from Twitch side, post the number... 2? Oh, sorry, man. We already started. Oh, particle. Oh, no. Oh, guys, don't vote particles. No. No, don't vote particle. Don't vote particle. Oh, that will be difficult, man. No. Rip. So you're voting for 7. What 7? Right hand, to hold something in right hand. GG's, man, GG's. Yeah. So viewers that come early, they get to decide what we do today. That's my idea to like give to you guys that are here in the streams early. You guys get to decide what I focus on, no matter what it is. Generally voted because I know how difficult it is and I want to see you suffer. Well, YouTube, we are the particles. Okay, we do particles. We do particles. Damn it. Oh no. We'll figure something out. Okay, we're doing particles. Bro, I don't know where to even start from here. Okay. First place to start is to load up Minecraft, because we're copying Minecraft. Let's see how Minecraft does it. So by particles, we would do, what would we do? Like breaking blocks particles, like those, because we had for weather a separate vote. So I assume you guys are not talking about snow and rain. You're talking about like block breaking particles, right? Let's try to see game mode, survival. So like this thing. Yeah, these particles. These particles, right? I was talking about smoke. Oh, smoke. Yo. Let's see smoke. So from fire. So you guys are talking about smoke as well. Flint. What about flint? Does this have smoke? I don't see smoke. How to get smoke? Minecraft Java inner or fog. Fireworks. Particles from lava. So these particles. Does this have particles? I don't see particles. Am I at maximum settings? Yeah, fabulous. Oh, maybe I disabled particles. Yeah, I've disabled them. Performance. No. Details. Particles. Do you guys see particles here? I don't see particles. Quality. I don't see particles. Other. Performance. I'm sure there was a thing for particles. Under animations. Animations. Particles minimum. Oh, okay, done. So, any particles here? I don't see here particles. I don't see particles from lava. Oh, yeah, here we have smoke. Every wrong menu. Okay, so these particles from the smoke. Campfire. Campfire. Oh, this is different particles. Lava drip. I get it. So here if we have lava. And here. Oh, no. So here lava drip, maybe. When block is under it. Oh yeah, this particle. Man, that will be so difficult. Oh. Man, how is this done, man? Okay, so these particles when lava drips, these particles from fire, these particles from campfire, redstone as well, I think, has particles. Redstone as well has particles. Right? Yeah, oh, this. Oh, the torch as well, I think, has particles. Torch. Yeah, the torch as well has particles. That's interesting. So this has, and here the dust has particles. And block breaking particles. Let's go into survival. Oh, when we break grass as well. Oh, and when we just hit the block, look at how particles spawn just by hitting it. It's just a quad. It's a simple quad. It's a simple quad with different sizes but the same texture. But we'll figure it out. It's most likely not easy, but... So when we break block, look at how many particles dropped. Particles from sand. Souls in nether. How to get that? Oh, crank obsidian. Does it have particles? No. Oh, the portal. Let's see if the portal has particles. obsidian and flint and steel. Let's see the nether. Place campfire on top of hay bale will make the smoke higher. Oh. Let's try this out. Like this. And yo, we need to do this, man. Look at it. These they're cool particles. And how do they? So probably they get spawned somewhere here and go to the direction of the portal. That's interesting. Yeah, this will be very interesting. Yo. And okay, somebody set the campfire above hay, so it should make it higher, right? Cave fog. To get, how do you convert into Oh, look at it, it's way higher, man. It's way higher. So we need a game plan. We have just 3 hours. This stream will be 3 hours. So what would be our best bet in these 3 hours? Because I have no idea where to start with particles, and we want something that's close to our skill level, because this will be our first attempt. Because when we look at the caves, this was in 3 hours. And in 3 hours, we didn't manage to do something spectacular. We need to keep, yo, Quaker, and what's up? We need to keep the expectations realistic. Like this is what I got in 3 hours with the caves. And so with the particles, if we keep expectations realistic, of course, obviously, we will not be able to implement all of these like particles, the redstone, block breaking, the lava drip, the portal. We will not be able to implement all of this in these 3 hours, sure. And we're not watching like tutorials, that's boring. I don't care about to make it perfect. And I don't care about if we find a solution or not. If we don't manage to find a solution, we just roll back all the code and we move on with something else that is a better match for us. But it's worth trying out to see what happens. Maybe there is a happy surprise. And most of the times it's that case, happy surprises. So for 3 hours, what would be the most worth it? I'm gravitating towards block breaking particles and maybe the portal, because the portal looks so cool, the particles. Or maybe the torches. We should start from somewhere. Where should we start? What's the best place to start? What would be the easiest? Oh, whoa, this is dropping particles. Look at it, it's dropping particles as well. Bro, they've added particles everywhere. Oh, the leaves. Oh, do the leaves have particles as well? I think there were particles like in the forest. I think there were particles. Oh, with honey as well, I think there were particles. Yeah, but let's not get distracted. Let's decide what would be the best first attempt. Check in newest version. In the newest version, in the pink biome. Fancy graphics. We have the fabulous graphics. We're at the maximum. Particles. Let me think about it. Particles. Or maybe the torch. Okay, which one of these would be the hardest? If it's difficult to see which is the easiest, which is the hardest, which should we avoid? Maybe the thing that has the most particles. But we can limit them, it's not a problem. We can limit them. The nether the hardest. Oh, this will be very difficult. Like, we need to spawn them and make them like move like smoothly, to move smoothly. And I'm very bad with math, physics, and movement. That would be difficult. But here, look at these particles. These particles need to just go up. And they change. Wait a minute, they animate. Oh no, these are difficult. These are difficult. Okay, block breaking. I think this is the best bet. And even simpler when we go in survival. When we just first attack the block. Look at how this spawns just a texture with a little quad, and that's it. And they just jump up. They just jump up and they face the player. They face the player. This is simple. Yeah, we can start with this. And like block breaking. I think this will be simple because it's just using a texture. And here this torch, I feel like it's more complicated. Like it's the smoke has some kind of animation. This seems to be difficult. And this seems to be difficult because of the way the particles move. The way they move. But at least they don't animate the texture. The lava drip. Oh, wait a minute. I think the lava drip is actually easier. The lava drip. Because it just falls down. Maybe it has a bit of a change in the while falling, it's stretched a bit. But we don't need to worry about the details. We need to keep it simple. Yeah, let's do block breaking particles. Let's start from here. I think this will be the simplest. Let's start with here. Yeah, let's start from here. Okay, so we have the player. We can walk around, and when we click on a block, we destroy it. That's it. When we click on a block, we destroy it. We can make it, when we click on a block, to not destroy the block, so that we can test particles on it. And also, about the blocks, each block has a mesh. A mesh basically tells the engine how to render, how to visualize the block. And in order to create the mesh, we are using a text file, which is in a JSON format. And it should be where? Inside of textures. No, inside of models. Yeah, here. And for example, if we search for the grass block. Yeah, the grass block. This file. Look at here. Here it says how to render the grass block, but I've always seen this texture, particle. This tells the block what particle texture it uses. So this is good. We have the texture to use. Now we just need to create a simple quad. And put the texture on it. And to render all of them at once. Okay, but we need to do something very important. We need to see if the particles happen in a single draw call or if there are multiple draw calls, and we need render doc for that. But is it that big of a problem? Like, we can test out different variants. It's not that big of a deal. We can test out different variants. We don't need to, because it will take time to open up render doc, to restart the game, and to make a screenshot exactly when we're destroying a block, just to see it in render doc if it's one draw call. It doesn't matter. We can experiment. That would be faster and way more enjoyable. So particle. The particle looks to be just a simple quad. And we put a texture on it. Sure. And yeah, we can do it like this in this creative mode. We already have the block destruction. We already have that. Where is the game? Here. No, I manually unbanned George Snow. I manually unbanned them because I felt bad. I felt bad that I banned him and I removed the ban. Like, he doesn't deserve a ban. It's fine. I may have overreacted. I may have overreacted. Yeah, okay, we already can like remove blocks. We already can remove blocks when left clicking. We just need to add the particles. We just need to add the particles. Like here. Okay, this is the first short-term goal. This is it. When we left click to create a particle in the place of the block. To fix the flash. This flash that we're getting is because we're on a single thread. We're on a single thread, and the chunk, when we destroy a block, the game needs to destroy the mesh and create a new one. And it happens, and mesh creation happens in multiple frames, because if all of the meshes got created in a single frame, it will have a lag spike. That's why for a second there is a little flash when we remove the terrain. But it's not that big of a deal. You need to double buffer your mesh. What does that mean? Oh, to have... Oh, yeah, okay. To not instantly remove the mesh, but to prepare the mesh, and when the other mesh is ready, that's when I should remove it. Like that, like the buffers in drawing, where we have, while the next frame is preparing, we are drawing the previous one, and when it's done, we swap them. Like you saying like that? Like swapping. But I don't care about that. It's fine. It's fine. We're focusing on particles. We're focusing on particles. So about particles. Let's first. This is the simplest thing we can do. Let's render at a certain position. Let's pick like 0, 0. Let's pick 0. On the top left, we can see the player position. And yeah, here, right around here, at 0, 0, 117. Somewhere here to spawn a single particle. That should have the dirt texture. Man, this flash may be a bit annoying. It may be a bit annoying. How it flashes. No, I don't have sound. Oh, I should have put sound physics in the thing, in the options. Do you generate every neighboring chunk, no matter where the block is? What do you mean? Do you have caves fully yesterday? Ah, the caves. This is the caves. This is the caves. This is our caves. Yeah, let's spawn a single particle. Add farlands. To add farlands, I need to see the actual Minecraft code, and I don't want to do that. I want at least the code to be mine. I'm okay with copying assets. I'm not okay with like looking at the source code. I want the source code to be mine. I don't want to use Minecraft source code. Okay, let's create a single particle. This will be the easiest first step. Let's create a single particle. So we need to create a mesh, right? We need to create a mesh. Hi, what's up, guys? I missed the key. You just need an integer overflow. Yeah, let's create a single particle. Where should I create it? We need to create a mesh for it. The mesh will be very simple. It will be a simple quad here. So a simple plane actually. Mesh particle mesh. The particle mesh will be generate mesh plane. We generate a plane, and here what parameters do we need? Here, this is a Raylib function. I don't know how to use it. It needs a width, length, and resolution. Okay. Width and length, let's make it the whole block. Let's make it big particle so we can see it. And resolution, let's make it like 1 and 1 here. because what's the resolution? Oh, how many vertices it is. If it's one here, it will be... yeah, don't worry about it. If we just put ones there, it will be fine. This just increases the vertices count. But we don't need more vertices. We just need 4 vertices. Let's make it 1 by 1 and resolution 1, 1. Or maybe like 0, 0, I think. Like to not add more vertices than what's needed. It should be something like that, probably. So what now? So what now? We generated a plane. This will be for the particle. And so now we need to render it. Let's draw it. So drawing here where we draw. And let's draw it after the terrain. Before we enable color blending. Which color blending is like for the water. But we don't need to worry about it. And here let's do draw mesh. Let's draw the mesh, the particle mesh. And for a material, we need a material. We need a material. Particle material. The particle material. There was a function in Raylib called load default. Load material default. And what does it do? We'll do something like this, but we'll change the texture. Or maybe there's a function that allows you to input a texture and it will figure it out. Oh, here it just creates a white texture probably. Yeah, one by one pixel texture it creates, and color is white. That's the default material. But we need an actual texture, like the grass block, the dirt block, because here in the JSON file for the grass block, because we'll just start with the grass block particles. The grass block has, yeah, the dirt texture as a particle, the dirt texture. So what functions are there for materials? Raylib cheat sheet. What functions are there for materials? Material. Can Raylib load external meshes? Probably. I haven't tried it because I don't need to. Why put everything in main CPP? No, it's not everything there. I have other files. And as main CPP increases, I gradually move them to other files. But I'm not ready for creating some kind of abstraction. Like we just started with the particles. We'll move the particles somewhere else. But it's way faster to just put some code there, see what happens, so we can make quick iterations. Here material. Load material from model file. This uses a file from the disk. We need to just give it a texture. Nothing too complicated. Set material texture. We give it material. What's map type? And we give it a texture. Set texture for material. Diffuse. To pick if it's diffuse, specular, etc. We just use a regular texture like for the colors. It's nothing fancy. Set material texture. Okay, this is what we can do. We load the default material and we'll just set material texture. Very easy. So we don't need to go into further details. We can use the Raylib abstractions. Particle material. And this is the particle material. And we give it the type. What were the options for the type? Material. Okay, material, map, diffuse. Like I think the map diffuse was like for the color, because there are other types for normal, specular, etc. But we don't need to worry about those. We had to deal with those when we tried to do shaders. And here we need to give it a texture. Oh, we have a problem. We have a problem. We have a problem because the texture is an atlas. I'll show you what an atlas is. Is this. This is the texture, and so the grass will be here. The dirt block. It will be here. This is the dirt block. And we have a bit of a problem. because here we give it all of this. All of this is the texture, and it will render all of this. And so, and we need just this part for the particle. It's not that big of a problem, actually. It's not that big of a problem. Let me think about it. Take the texture of the block to your breaking. The block is also using this, the whole atlas. Not this particular one, but the one we create in runtime. The one we create in runtime. And I have the coordinates. Like I can do a check. I can do quickly a check for where the coordinates of the dirt texture. I have the coordinates, and we can give it a bit of information. But the problem is the mesh, we didn't create it ourselves, and so we don't have access to what coordinates it's using here. Here, this is what it's using. We need to change these coordinates. We need to change. Let's see what actually gets created. We may be able to just manually from here, particle mesh, and just change the text coords to be what we want them to be. Here, the first one to be whatever. Like, it doesn't matter. Let's see what actually gets loaded here. We can just use the... yeah, we'll be using the... what was it? We will be... yeah, here we'll be using world, get texture, the atlas. We'll be using the atlas for the texture. So it doesn't matter. Let's just render it. It doesn't matter, it's using the whole texture. We'll change it a bit later. I just want to see if we are drawing the mesh. Particle material, and here a transform. This will be the position of the mesh. The position will be at... wait, transform? Is it like... what does it... is it a matrix? I think it's a matrix. Oh, it's a matrix. So we need to make it a bit different. Draw model. Let's copy the code from draw model. How they created a matrix. Let's copy this. And here, let's paste it. Like this. And now we can... now we can create our own matrix for transformation. The scale will be like 1, 1, 1. We don't need the scale. Rotation... we will need a rotation actually on the x-axis, let's say. So here on the x-axis and here to rotate 90 degrees. Probably, we'll see if that's the case. And here as a position we'll do 0, 1, 15, 0. Because that's what we saw in the game. And here we just put the matrix transform. That's it. We should be getting the mesh in the game. Hello, Hiragana man is back. What are you working on? Particles. Why 115? Because here we looked at the coordinates. We looked at the coordinates and we saw that it was around 115. Here it's 117. So if we go above, oh, it will be down. So it will be around here actually. Here. Where is it? Guys, do you see it anywhere? I don't see it. Let's use the default material. Let's use the default material. Let's not use the texture. Let's use the default, so it should be a white color. And let's remove the... let's put it on... let's make it be higher up, so 120. And let's remove the rotation. Let's remove the rotation. And I need to remove a bot from chat. Right? Did I do it? It didn't work. Oh, okay, it worked. So I put it at 120. Yes, here somewhere I put it. Does anybody see it? The problem is this is just a plane, and there is and it can be seen from one side. You cannot see it from two sides. You cannot see a plane from two sides because of the drawing order, and I've set it so like here from below. Look at how from above you can see this. From below you cannot see it. That's what I'm talking about. And here this side, from here you can see this, but from here you cannot see it. Like that's what I'm talking about. So it's a lot harder to notice it. Okay, I have an idea. Maybe I'm using the wrong coordinates. Here, let's make it a lot bigger. A lot bigger, and here let's put 1. Like maybe I'm just using this function wrong. Okay, here it is. Here it is. Yeah, now it's fine. Now it's fine. This is the plane. And so let's rotate it. This is our first particle. This is our particle. Yo, bro, imagine Minecraft with these huge of particles. That would be wild. That would be wild. Let's use our own texture. What happened? Yeah, let's use our own texture. The atlas. This is our whole atlas. It gets generated at runtime. Bro, look at how many blocks we have. Yo, this is the fire. Look at it. It's animated. It's animated, the fire. Look at it. What's this tentacle? Bro, what the fuck? And here it's Z fighting with the leaves. The leaves have issues because they're Z fighting. And here this is this animation. What else? Oh, we can have plants. We can have plants. Oh, we'll put it tomorrow. Hey, I forgot first-time culling optimization as an option for today. I forgot about that. This is the other anime. Bro, these leaves are so annoying. Okay, I think I removed them, all of them. Yo, look at this, man. Look at this, how it pulses. Look at this, how it pulses. It's very cool. Look at the pulse. And this. Yo, that's cool. What else do we have here? Oh, the command block. Look at it, how it changes the colors of these. Bro, we have so many textures we can use. Oh, fire. Look at it. It's like dumpy. Look at it, how it... Bro, we have so many textures to use. Yeah, this I think should be in the water. Should be in the water. Oh, this is the portal. Okay, let's focus. Let's not get distracted ourselves. In the role makes the world look huge. Yeah. Oh, paintings. Yeah, paintings as well. That's a good idea. Paintings. To have paintings. Okay, so this is our particle. We need... Look at this now. We need it to shrink and be just this texture. We need it to be just this texture. I'm assuming this is the dirt, but it could be something else. But we have the coordinates inside of the code. We don't need to worry about it. We have the coordinates. We don't need to look for the dirt. And so let's say it's like just this texture. We need this little part to be the whole thing. To be the whole thing. What's this? What's this? What's this? Chat, what's this? X? Okay, let's try to let's see if we can rotate the texture. Let's see if we can rotate the texture. So this is the particle mesh here, and let's try to rotate it. Let's try to rotate it. So here on the x-axis with an angle of 90 degrees. Oh, we can make it follow the player. Yeah, here, okay. Now we've rotated. We rotate the texture. Yo, what's this? Chat, what's this? That's some kind of a creeper. And look at how from this side it's invisible. But from here it's visible. Yo, Detective Jones. Thank you, man. Yo, W's for Detective Jones. Where's the chat? I need to heart it. Yeah, I need to heart it. No, I cannot heart it. Yo, thank you, man. I appreciate it. Thank you, man. Appreciate it. But Detective Jones, like, chill out, man. Like, chill out, man. Like, you guys just watching the streams, that's enough. You guys being here every day, like, especially the first viewers when the stream starts and when you guys vote. Because if it wasn't for you guys voting, I wouldn't have started on the caves, and I'm glad we did the caves. And now with the particles as well, just being here at the start of the stream and voting and interacting, look at how because of you guys, we started work on particles. I wasn't going to do particles, like, I don't know when. I wasn't going to do it, but thanks to you guys. So just being here and interacting and chatting, like, for me, that's completely enough. But if somebody decides to support the stream, I also appreciate that. It's not like for nothing. So thank you guys. But let's focus on the particles. Let's focus on the particles. My focus now is the direction. My focus is the direction they get rendered. I think all of them face the player when they create it. I think all of them face the player. But do they change rotation? Do they change rotation? When the player moves, do they follow the player? That's what I want to see. Guys, can we slow down the game? Is it possible to slow it down? Oh, I have an idea. Yeah. Time set day. No, I was going to record it and just lower the speed. But we cannot do that. We can look at from the fire. Okay, here. This. From the fire. We can just use the fire. Yeah, I think, look at this. They continue to follow the player. They rotate, I think. I think, yeah. I think they follow the player. They always look the player, right? Because right now we are doing the rotations. And we're early on, and if we're going to make it follow the player, it should be now. That's why I'm checking this. Do tick rate 1. Yo, thank you guys, thank you. Bro. But the player is also slow. Yeah, it's rotating. I think it's rotating. Oh, bro, look at it. Just moving the camera around, it rotates. Look at how all of them are depending on where we look with the camera. Bro, yo. So it depends on where the camera is looking. Tick rate 0. Oh, tick rate 0. But that will freeze the player probably as well. Tick rate 0. 0 cannot be used, but it's a float. It's a float point. Let's try to destroy a block. Tick freeze. But why would I need tick freeze? Oh, perfect. Yo, genius. Bro, whoever said tick freeze is a genius, man. Bro, look at this. Can I destroy a block now? No particles. I want a tick freeze on the destroying of part, but I think we got it, man. I think we got it. Yeah, they should always look at the player. They should always look at the player. No. Oh, it's not. I noticed something else. It's not the particle itself. It's this whole line. It's this whole line. Because look at how this end is like there further away from me. And it's always this end further away from me, I think. So I think it's the whole thing. It's the whole thing. The whole mesh, the whole model gets rotated. It's called billboarding. This is Minecraft. That's not my clone. It's the whole thing. It's not just the... Oh, what about here? What about these ones? These ones are individual. They individual... Oh, we went to the nether. Let's go back. I want to go back. Yeah, going here was super fast, and going back is impossible. Tick. I think we broke the game. Tick, unfreeze. And tick rate 20. And let's go back. And tick freeze. And tick freeze. Okay, let's make this follow the... but it's not only that, it takes into account the camera as well. Where we are looking at. It takes into account the camera as well. And if we don't move the camera... Oh no, I think it's just the camera. Look at how they're not moving, I think. If we don't look at them, they stay the same. Do you notice, guys? They stay the same. If we don't move the camera, they stay the same. They don't change at all. It's only when we move this. Only when we look around. Only when we look around, I think. I'm not sure, actually. You just say it's Y rotation to the of the camera. But it has the other rotation as well, up and down. It has like this rotation as well. Like here, like looking at it from here. Do you notice? Now all of them face up. Okay, so okay, it's very simple actually. We just look at the camera rotation, that's it. Look at all of them are looking up. And now all of them are looking down. because we are looking up. Yo, that's crazy. Okay, let's do that. Let's do that. Let's do that. Let's make this, because they rotate towards the player, because look at from here, it's you cannot see it, but only from here you can see it. So let's make this part be, so when we're looking up, this should look down. If we're looking up, this should look down. And if we're looking down, this should look up. Let's do that. That would be much more helpful. And after we do that, we'll make this particle be one of these textures, like the dirt one. And then we'll lower the size of this particle. And then when we destroy a block, we'll spawn it, the particle. And then we'll make it move in a random direction. And then we'll spawn multiple particles. And that will be pretty good result. And then instead of trying to perfect it, we'll do the torch. Instead of trying to perfect it, or maybe the portal. One or the other. Yeah, I think this will be the game plan. Is snow getting cold? Snow is not getting cold, but it's not a problem. It's fine. And here it's grayscale, because in Minecraft here it's grayscale as well. I've shown it in previous streams when we added this, but when you destroy it, it's grass, so it's fine. Nobody will know. Nobody will know. Let's make this rotate depending on the camera. Hello, what's up? What's up? How should that be done? How should that be done? So for the camera, we actually made it custom, the camera rotations. I think in the player we handle it. Yeah, here, process mouse movement. And here we handle the yaw and the pitch. And so we can use this, the yaw and the pitch of the... we're storing it where the player is. So we'll get the yaw and the pitch from the player, but it's not that big of a deal. And we have, just in case, we have this quaternion, the orientation, if it's easier to use, just in case. Or we can, yeah, let's focus on one of the axes. Yeah, let's focus on like either the pitch or the yaw, the pitch, which is up and down. So we will focus on, if we're looking up, the texture should face down. And if we're looking down, the texture should face up. I think this would be the easiest to focus on. This would be easiest to focus on. Yeah, this would be the easiest. So we'll focus on the pitch. So we will need to rotate, to set the rotation every frame. We'll need to update it every frame. So let's go back to the main. And here is the rotation. And this is in terms of on the x-axis. Yeah, this is in terms of x-axis, which is fine. Let's put the rotation in a float. Particle rotation by default to be like 0. It doesn't matter. And here, every time we draw it, we're using the rotation. Particle rotation. Perfect. And what else? We need to update it. Player. Let's search for player. Where do we update the player? Here we process mouse movement. After we process the mouse movement, maybe to do it then. Here. So particle rotation. Let's make it be, let's make it simple. Let's make it be the player pitch. Let's make it the player pitch and see what happens. Yo, yo, yo. It's rotating. So here it should face up and not be 90 degrees. It should be 0. So this is like minus 90 for me, pitch. Minus 90 pitch. And this is minus 90 rotation probably. So let's do plus 50. Plus 90. Let's do plus 90. Let's do plus 90. What happened? Let's start again. Please. Okay, okay, oh, okay, look at it, look. We are looking down and it's facing us. Yo, 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 yo. And now it's facing, yo, bro. Bro, yo, it's following us. Yo, it's following us. It's following us. Yo, that's cool. But now we need to do the other direction as well. We need the other direction. So when we're like this, to face us. So here we're facing the east positive x. It should face the negative x. So let's do the same. Let's add another rotation. Let's add another rotation. We need to rename this particle rotation x. Particle rotation x. And let's make another one, particle rotation on the y-axis. On the y-axis. And now give me the errors. Where are the errors? Where's the particle? Here. So this is on the x-axis. This is on the x-axis. This is on the x-axis. And where did we use it? Particle mesh. We used it here. So this is on the x-axis. We need on the y as well. So this rotation we need to do on the x, y, z. And we need to remove this. And here we need... What do we need actually? A vector. A vector like this. This is on the x. We need the same on the y. We need the same on the y and the... no, the z is 0. Z is 0 and this should be y. Now we should have both rotations, but we need to actually set it here. Let's make the y to be just the yaw. Just the yaw. And let's see what happens. Well, what are we doing? Particles. We're doing particles. And so, Bro, what is this y rotation? So the x-axis rotation is the same. Is the same, but the other rotation is... Why is it doing it on this axis? Why is it doing it on this axis? Let's change it. Okay, let's change it to be the other axis. We changed it to be the z-axis. It's not yaw. Let's restart it. Let's restart it again. Okay, and how is it now? Okay, okay, it's the z-axis rotation. And so we need it to be... Okay, let's do plus 90 degrees. Let's do plus 90 degrees. Okay, let's change this to be the z. Oh, x, y, z, right? And here angle. And Z, Y. Okay, so it's in the Z. My bad. So it was on the Z. Here on the Z, and here on the Z, and here let's just add plus 90. Let's just add plus 90. Oh, yo. It's kind of following. It's kind of following. Oh, wait a minute. Draw billboard function. There is a function like that. Really? Draw billboard. Bro. 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 And we can just give it a texture and a position. Yo. There was a function for this. Why did I have to go through the struggle? Why did I have to go through the struggle? Oh my god. Thankfully, you guys know Raylib. Yo, what's up, Clay? That's a particle. We're doing particles. So here, let's forget about all of this. Let's do draw billboard. Draw billboard. We give it the get player camera. We give it the world get texture, just the atlas. We give it the atlas, and we give it a position, so 0, 1, 20, 0, the same position. And scale, let's make it big scale and white color overlay. Bro. No. It's kind of there, but not fully, because it doesn't have on the, like, looking up. It doesn't have when looking up. But it's pretty good, man. It's pretty good, actually. It's pretty good. Bro, Raylib is amazing, man. But we need on the other axis as well. What's this? Oh, rectangle source. We can pick a part of the texture. So we can pick our, just the dirt. That's even better. And here, the pro. Up. What's this? Up. So probably we can set it up from here. The up. This particle might be a gym, bro. Will there be no multiplayer? Okay, let's try the second one where it's... Wait a minute. This is source, position, size, origin, defined by source and rotation. Oh, rotation. So the pro is for us to, like, give it more data, to handle it ourselves. Draw billboard track. Let's look at this one. What does it do? And here the rec, and then the... Oh, here the up. Okay. The up is always the same. It's locked. The axis Y is locked. Yeah, I get it. But we can figure it out. We can figure it out. Matrix look at. Camera position. Camera target. Camera up. Okay. And here. This is the right. And here the up. I want... how do they get the right? This is the matrix. M0. First row. What's this? Oh, this one. It's just the first row. M0, M4, M8. And how can we get the up then? If this is the... Because I want to use from this view. I don't want it to be locked. I don't want it to be locked. This up, where do we use it? We use it here. Use the Pro one without the lock. Ah, without lock here. Without the lock. So this. No, we can. Let's remove this and see what happens. Yeah, but here it needs an up. It needs an up. It gives it from here. I want to take it from here because they take the right from the matrix. I want to do the same. Okay, I have an idea. Here, we'll just do the same. Up. We'll do the same. We'll comment this out. And here, we'll use the other row. We'll use this row. And if it doesn't work, we'll use the other row. This is from 0 to 8. This is from 0 to 8. We'll do from 1, 5, and 9. We'll do 1, 5, and 9. We'll do that and see what changes. So, wait, do you have something figured out? Redefinition. Redefinition, we can change this. Now it's different. Okay. And let's see if the rotation on up and down is changed. What? It's it's squished. Bro. Let's pick the other row then. Let's pick the other row. So let's do 2, 6, and 10. Let's do 2, 6, and 10. Let's do 2, 6, and 10. Where is it? Ah, there it is. It's very visible, so it's most likely wrong again. Oh, wait a minute. How was it used? They may be doing changes to it. Yeah, here they're probably doing changes to it. But it's fine. Let's do the other row then. This is the last option. 3, 7, 11. 3, 7, 11. Are you making without an engine? We're just using Raylib. What are you trying? Yeah, we're doing particles. Where is it? Should be here somewhere. Our big particle. Okay, let's do it how it was before. This strategy will not work. Let's do it like it was before. So here they have the right from here. They're doing some kind of up. Flip content while maintaining the counter. I don't care about this. It's fine actually. Actually, it's fine. It's fine, guys. This is good enough. This billboard is good enough. And it's better than what we can make on our own. Sure, it cannot go like to face up and down. It's locked. It's locked, but it rotates good enough for now. We can continue. We are not blocked. We can continue. This is good enough. It's better than before. Because in Minecraft, we can get it like this. And like this. Like in Minecraft, the particles go up and down, but it's fine. Yeah, it's fine. At least they will have these rotations where they face the player. So when we break a block, I don't think it will be barely noticeable. Let's do tick unfreeze. Yeah, when we break a block, it will be barely noticeable. It's fine, guys. We'll just use the regular board. And future me will be smarter. He'll figure it out, how to improve it. but he will be regretted a lot if all we focus on is the rotations and don't have any particles. So let's move on. That would be my regret if we try to over optimize it. It's fine. So what's the next step? Let's make it be the dirt block. Let's make it be the dirt block. And there is actually a function for that in Raylib. There is draw billboard rectangle. So we can give it a source. So let's give our thanks to Raylib because they save us a lot of time. The up vector of the camera. Oh bro, you're a genius. Bro, if you're correct, you'll be the third chatter I'm marrying. Bro, I'll marry you if this is correct. Let's make this be pro. No, it should be like... Yeah, pro, I think. No, we can do it here. No, here, we can do it here. We can do it here. We can do it here, here. And here, instead of this, we'll use the get camera. I need the forward. I can get it from the player. Let's just copy this. I can get the up from the player. So this is the camera, the texture. We'll just do one attempt and then we'll move on because it's worth it to do this. It's very quick to test it out. This is this, and what else? Source. There was a default option for source. Source to be this. This is the source. And here let's just do texture to the texture equals world get texture atlas. And here we change this to be just texture. And here the size. What's the size? Size is like 10, right? Float size equals 10. Or what does it expect? What does it want as a size? It wants vector 2. So the size... Oh, they calculated here the size. From the scale. Yeah. So I need to copy this as well. Let me think about it. In here, the size. Okay, it's a vector 2. So here we do vector 2 size equals this. And this should be scale. And we remove this. And that's it. And here this will be white. And what else? Oh, the up. Let's test it if it works, and then we'll change the up to be the camera up. Where's the billboard? I don't see. Oh, here it is. Okay, let's make it be when we look up the billboard to look down the particle. Let's do that. And so here, somebody in chat recommended this to be the up, the camera up, which is from the player, but that doesn't matter. That's actually the camera. That's the camera. Yo, bro. We did it, guys. Yo. That was so easy, man. Yo. That was so easy. When Raylib handles it. It's following us around everywhere. Yeah, this is our first particle. Yeah, guys, I've in my first ever streams, I've told chat the chat is smart because, guys, let's be realistic. Who's going to watch programming uh, stream? Smart people, like guys. I'm sure you guys are smart. I've told you from the earliest streams, and multiple times I get chatters telling me some genius advice. Okay, this is very good. This is very good progress. This is very good progress. Oh, bro, this is actually, we can do the same logic with the mobs as well in the future when we do mobs. Because I was wondering how the mob head follows you, right? The head of the mob follows you. It looks at you. And I was wondering how it does it. But no, it doesn't need to be like depending on where. No, it's fine, it's fine, it's fine. No, I'm over. No, don't worry about it. Don't worry about it. Okay, let's now make this texture use the dirt. The whole dirt. Oh, I forgot to make a commit. And now it's both the particle and the caves, I think. It's okay. Caves plus particle draft. Smiley face. Future me will love this. So we have the particle. We will remove the let's remove all of this. So we have our first particle. Let's make it be just the dirt. Let's make it be just the dirt. Stream quality should be excellent. Stream quality should be excellent. So guys, if you have problems with the stream quality, check your network. And if it's still bad, then tell me, because I need to know this. So we have the particle. Let's make it be just the dirt. And how are we going to do this? I need to see. We will do the same code as when the generation of meshes. What does the dirt particle look like in regular Minecraft? It's just the dirt texture. It's just this texture, the dirt one. And we take the texture when we draw this mesh. Like from this atlas, we find the dirt texture, like this dirt texture. This dirt texture, we managed to find it in the code. Let's go to that place in the code. Let's go to that place in the code, which should be, because we'll just copy what we do there to get the dirt texture, because we need it for the particle. Where do we get it? I'm a bit lost. Where do we get the texture from? Yeah, I think it was called texture ID, I think. Let's search for texture ID. Yeah, texture ID. Sure, what now? Yeah, we look for it, I think. What's this? Yeah, this is just string. Texture origin. Get texture coordinates. This is what we need. Get texture coordinates. This is what we need. And so let's use the coordinates. We need here in the main, when we draw the particle, billboard here, billboard, and here in the source, this is where we need to give the coordinates, and we need to change the size as well. The size will be, I think it was like, it needs to be like 64 divided by this, because our texture is higher resolution. And here, let's see what happens now. It should be a 0, 0. It should be a 0, 0. This is not the dirt. This is one of the possibilities, one of the blocks. I don't know which block this is. Let's actually use the coordinates. So it should be like vector 2 texture quartz equals world get texture quartz, and we need to use the name of the dirt texture, which we have it from where? Grass block JSON. We have it here, this thing. And so we put it here. So this should get the coordinates of the dirt. And we need to, what do we need to do? And the coordinates, they're in different units, I think, question mark. But let's test them out. Text quartz X and text quartz Y. And let's test this out. Is it just me, or am I acting as if I know what he's talking about? Looks like one single pixel. Wrong texture. Yeah, this is the dirt, right? This is the dirt. And what do we have? Oh, we need to remove the Minecraft thing. We need to remove the Minecraft namespace here. The Minecraft namespace. I don't use it. What else? Will it work for a second time? We need to restart it. Sometimes I need to restart the game a couple of times to get it working. So what's this? Let's actually pick coordinates ourselves manually, just to be sure, because I don't know where we're doing it wrong. The size. Let me think about it. Here, let's look at this texture just to see what size it has. I want to see what size we're working with. What size are we working with? Let's restart it. Restart. And let's see the texture. I don't want to run it in debug mode. I hope that it will get it in release. Let me use my old texture. Here, this is like 256 by 256. And we need to give it these coordinates. So this is 48.0. And so what's the size? Oh, no, it's fine. It's fine. It should be like 64. Oh, I'm just dumb. I'm just dumb. Should be 64. Yeah, it's 64. It's 64. I don't need to divide it. It's fine, guys. It's fine. And we need to restart it because there is somewhere a bug that we haven't fixed, which makes it that we need to restart the game a couple of times to make it working. Yo! Yo! We got particle, and it's a big one. Yo! We got particles. And so what now? Now, now, let me think about it. Now, what now? We need, when we break a block, let's go in survival. When we break a block, we need to spawn this. And we need to make it smaller, and we need to make it move somewhere. Spawn when I walk, but I will not be able to see it. I'll be able to see it when... Oh yeah, you're right. There were animations like that in Minecraft, like particles when walking. Survival. Like when you jump. Like when you fall off. Man, this guy. Oh, when we fall. It creates particles when we fall. It creates them. It's fine, it's fine. Joint, why is there giant dirt texture? We're doing particles. We're doing particles. So let's do a very quick summary. It can be the quickest we can do is we're doing particles, but we noticed in Minecraft here we saw a couple of there are many particles in the game, many of them, and we noticed that they only like look at how they always look at you. And another thing we noticed, they're simple quads, like this one. They're a simple quad, and they always look at you, but they don't look at you depending on your position. They look at you depending on your camera, depending on where you're looking with the camera. And now all of them should look up, and all of them should look down, like this. That's what we figured out. And anything else, like look at all of the particles are looking up towards me. And that's not based on the position, that's based on the camera. That's based on the camera rotation. And we decided it will probably be the easiest to focus on block breaking particles and see how this particle uses the dirt texture. And that's why we're rendering the dirt texture. So the idea was when we destroyed this to get this spawned, and it should be smaller and it should move around. And we don't care about its rotation. It will handle the rotation itself just by giving the camera to it. Just by giving the camera to it, but what else? What else? And I was thinking, will this be actually easier? Because it just needs to go up, this particle. Or maybe the fire. Oh, the fire. I think the fire would be maybe easier. Like, not the smoke, but the fire. And it just spawns the fire again. Yeah, it spawns it multiple times, and when it gets spawned, we just scale it down. Are you doing it with instant sync? We don't use instant sync. If we optimized, it will be difficult to do changes, like to have fast changes. We need to quickly make refactoring because we're rapidly learning new stuff. Like, we learn stuff very quickly, and once we learn something new, it may change the whole structure. And if we try to optimize it with instant sync, it's early for instant sync. How are we going to make the particles have like physics? Do they need physics? I was wondering, is the chat... what do you mean? I think the breaking particles are only a tiny part of the block texture. Yeah, they're very tiny part. Orthographic camera for particles. We don't need that. Use small squares for fire particles. Oh, just small squares. You're right. And for the redstone as well. We can use just... Oh, we can just... We have two options. We can use small squares or just a big one and generate the texture dynamically ourselves with a noise map. Yeah. And just scale them down or up. Okay. We can do that. For the smoke and this, we can do that. I think this would be easier probably. Because here I will need to like make them move. Like the movement is here the most important part. But if we do the torch, here it will be a lot easier, I think. And we can just focus on the fire. And where is this fire coming from, actually? Where is this fire coming from? Let's find the torch model. Or maybe to just do the block breaking. I haven't decided. We'll think about it. Let's see if we can find the torch particles. If we can find them, we may do the torch. If we don't find them, we'll do the block. Right? I need to open some resource pack, I think. I'll need a resource pack. I need to find one on the second monitor. So in backup, more backup. here, 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 here. Okay, let's search it up. Particles. Oh, what's this, man? Oh, bro, what's this? What's this folder called particles? Oh no. I'm not using this folder. What about textures? Let's use torch. Torch. Okay, let's see here. Torch. In particles. No. Fire. Firework. Oh, this is something else. Bubbles. Textures. Oh, it's just handles. Okay, okay. It's just the reference to the textures. It's not that big of a deal. Enchantment. Enchant. Yo. Multiple textures. Oh, is this the letters for the enchanting? Is the letter? Bro, imagine if we do the enchantment table. Bro. Imagine if we do that. Explosion. Bro, look at this. The gold mine. Falling. Fishing. Flame. This is the flame. This is flame. It's just one texture. So you could have multiple ones. Nodes. What's the nodes? It's just a single node. Portal. This is the portal. And it uses generic. Oh, generic. Let's look at generic. Generic. Maybe they are predefined. Yeah, they are predefined. Okay, so this is for the torch, these generic ones. And they're for the smoke, for the redstone torch, and for the smoke of the torch. Yeah, that's how they do the... And it's for the portal as well. It's for the portal as well. The technique is just to use a Raylib function called billboard. Search it up in the cheat sheet. You'll find it. This is very helpful, man. What about a regular block one? Like block breaking. Do we have block breaking here? Yo, this is very useful. Smoke. Yeah, again, the generic one. But they changed the order, I think. They changed the order, I think. What else do we have here? Trail. Underwater. Do we have for blocks anything? Here. Block. Break. Mine. No, nothing. Oh, but we have an issue. I don't have the... I think I have them. Generic. Do I have these textures? I think I have them in the atlas. I think I have them, right? I should have them. Generic. No. I don't have them. Block. Def. Engine. Generic. No, I don't have them. I don't have these particles. I don't have them. I think block breaking is based on the block you're breaking. Yeah, but this was for the smoke and other stuff. In the game, you don't need generic. Bro, I know, man, but I was focusing on this for a little while. Like, this is the generic. And I focused on the torch because the fire seems simpler to do. This fire texture, the torch one. Because it stays at one spot and it just scales down. It's very simple. And this uses the generic. Oh, it animates. It animates. So it goes through these versions. It starts from here and it goes down to generic 0. It animates. Yeah, we can easily do this. but it will take too much time in this stream. It's not worth it. This is not worth it in this stream because we will need to load all of these textures. We need to put them in an atlas. We'll need to manage them. It's not worth it. And I need to check in render doc if Minecraft creates a separate atlas for the particles. And so I think it will be best to continue with the block breaking. Because this one just uses the dirt texture. And just use the dirt texture. Just uses the dirt texture. Okay, let's try to spawn the particle. Let's try to spawn it. Don't worry about the name. 4 big scripts, what do you mean? They create separate atlas for particles. Because it has their engine. I'm pro Minecraft builder, I can build any type. Good for you. Good for you. Let me see now. Hello, what's up? So we're spawning a single particle. Okay, we've decided we'll do block breaking particles because we already have the textures. We just need to spawn the particle, to scale it down, and to move it around. We need to figure that out. Okay, let's go to Minecraft and let's change the tick rate to like 5. Let's break a block. Yo, let's make it to be 2. Yo. Oh, look at it. How many particles? The particles start exactly where the block is. And they just spread around. Yo. And they are different parts. They are random parts of the dirt texture. They use random coordinates. Yo, that's very cool. Yo. Oh, they collide with the ground. Bro, how are we going to do collisions? That looks very difficult. How are we going to do collisions? They are probably entities. Are the particles entities? Because if we do like instancing, how are we going to do collisions? We're not going to do instancing like now, but that's like for the future. Are not entities. Yeah, but they collide with the terrain. They have position, they have velocity. My entities also collide with the terrain. They also have position. They also have velocity. It's not an entity, but particle. It's like different kind. Yeah, we can use some kind of a particle entity, something very simple. But for starters, we can use the player entity. Oh no, we can use something else. They can be simple points. They don't need a collision box. They just need a simple point for the collisions, probably. Yeah, they just need a simple point at the center. That's what they need. Yeah, there will be a different kind of entity that has a simple collision. The collision is just a point in the world, which should simplify collision checks. But let's not focus on collision. That's not the priority. Priority is when we destroy a block to spawn all of these particles, and let's not move them at the start. Let's not move them. Let's just make them like spawn where the block is. That's the first step we need to do. That's the first step. Yeah, that's the first step. Okay, sure. Random points. It's inside of the block, not near the block. Here, it's inside of it. When we break it, we need the region of the block. We have the block origin and we just do And the origin, I think, is like down there in the corner. It's not at the center. So we just need to do +1 on all of the 3 axes. And we have the region where we can spawn the particles. And we can just do how many are the particles at one axis. Here's something we can do. Like this, and let's go in Excalibur. Yeah, this guy from the previous stream, he's amazing, man. He saved me so much time with his suggestion. Okay. Here, this. What scripts are you talking about? How many particles can we put on one row? Okay, it's 4 by 4. Okay, it's 4 by 4. It's 4 by 4. Here 1. Here it's 1, 2, 3, 4. Like 3, 4. And here 1, 2, 3, 4. And here 1, 2, 3, 4. So it's 4 by 4 by 4. That's it. It's inside of the block and they're 4 by 4 by 4. That's it. That's how they do the particles. And we'll do simple collisions, just a point in the world. We don't need to give them a collision box. Like the player. The player has like a big collision box. They'll just have a simple point and they'll have position and velocity. They need to have them. We cannot do it without it. And about instancing, that's optimization that we can think about in the future. We don't need to care about instancing. We're not ready for that. And also we want to fit in the time as much features as we can. Yeah, let's do that. And they look like they have different scale. They have a random scale of the texture, how much they're scaled up and down. And they look to have different small parts of the dirt texture. They use different small parts. And they look at the player, wherever the player camera is looking. Yeah, so this is very good guidance. So this is what we got now. Just this one big particle that stays in one place and it's looking at us. This is what we have. We have a good direction. We have a goal. We have everything prepared to reach the goal. So things are looking very good. Things are looking very good. I am very optimistic. So what's the idea? We'll ignore the particle. And when we remove this block, we'll just draw spheres at these locations. That's what I want. I just want the starting locations at first. And to make the... Will it be 4 cubed particles? Don't worry about it. Yeah, let's do that. No, I don't want client-server architecture. I don't want that. No, I want that. I want that because even if we do single player, it will help me with optimizations. Like I need multiplayer for sure. I need it, but not right now. Not right now. Okay, so when we remove the block, we want here 4 by 4 by 4 points in this spot. That's what we want. And first, let's just draw a couple of spheres here instead of the particle, just to see if we have the positions right. Just to see if we have the positions right. So what did we do now? Now what we did is we are able to change the texture of the particle. That's what we managed to do before this. So here if we change it to, let's say like a stone, if we change it to stone, now it should be the stone particle. Now it should be the stone. If this manages to run. Yeah, now it's the stone particle. Now it's the stone. So we can very easily change the texture. That's not an issue. And we can scale it down, etc, etc, etc. So when we remove a block, let's spawn in 4 by 4 by 4 positions, and we'll change them to be the particles. So here, let's change this back to dirt, and let's make a commit, and let's call it wait a minute, let's actually, what happened to the toolbar? Don't worry about it, it's like that for a long time. It should be an easy fix, but I'm prioritizing other stuff. Yeah, let me change the stream. Let me update the stream thumbnail, just so people do not expect caves, since chat voted to add particles. And we can actually change the title as well. Particles. Yeah, I added particles. Yeah, okay, we'll do this in other streams as well. We'll update titles. Sure, so what now? Almost 2. yeah. We have a 3-hour limit, so we need to be fast. And so we're like almost 2 hours, so we have an hour and 10 minutes. But we're doing good on time. So the goal right now is, when we destroy this block, to spawn here 4x4x4 particles. Make it separated function that accepts the block words and its texture by first showing a single particle in the block when broken. That's for a bit in the future. What graphics API? OpenGL, because we're using Raylib. Let's do the points. Did we do a commit? No. Particle can use any texture. Like that. Yeah, we're adding particles. Let's see now. Again, in the main here. Oh, we are not using the particle mesh. We're not using it anymore. So we can delete it. And we should delete this as well. So what now? Now we need, where was the while loop? Window should close this thing in here. I think main loop. Yeah, this is the main loop here. Here I want an array. Here I want temporarily to put the positions. Vector3 particle positions. Temporarily I want to put just the positions here, and should be 4x4x4. And by default, hopefully they initialize to 0. And what we're going to do is, when we are drawing here, I want to go over the points and draw spheres there. So for int I equals 0, can we do like auto iterator equals begin particle positions? Can we do this? I wanted to be able to do this, but sadly not. So we need int I equals 0, I less than 4x4x4, I plus plus, and here for each one of the particle positions we need to draw a sphere. We'll draw a sphere. The center is at particle positions I. The radius, let's do like 1, and color, let's do like, I don't know, white. like this. And now let's fill up these positions when we break a block. So when we hit the left mouse button, mouse left, where did we handle the mouse? Where? Here is the mouse left. This is where we destroy a block. Here is where we remove a block. Yeah, we're adding particles. Here is where we remove a block. So we have, let's do a vector 3 minimum position equals the block hover, block origin is the block origin, and it's a nice to see you again. What's up? And the max will be the min plus just once on all of the axes. Or we can just use the minimum. Let's fill up the points. So for I, let's do, what should we do? For int x equals 0, x less than 4, x plus plus. We do this 2 times. This should be the y. This should be the z. And now, what we do? We do particle, and here we need the I, the index. We need an index equals x plus y times 4 plus z times 4 times 4, I think. And here we do particles positions index equals, and here we set the position. It should be the minimum. It should be the minimum plus how much? X, y, and z, but vector 3. And here it should be it's from 0 to 4. We need to divide it by 4, I think, actually, right? So it will be between 0 and 1. We need to divide it by 4. So it should spawn the position. It should set the positions. And let's test it out. Let's remove this block. We expect here to have 4 by 4 by 4 positions like this. Not particles, just the positions. The size is too big of the spheres. Let's lower the sphere. One sphere is a radius of 1. Let's lower the sphere. But I think we're there. Here let's do 0.1 f. 0.1. Yeah, there is no Mac support because Mac hates OpenGL, sadly. And here, let's destroy this and see if we have the positions right. We need to offset them a bit, so like plus a little bit. But this is the positions of the particles. This is where we'll spawn the particles to be just like Minecraft. So we are doing this thing. This is what we're doing. Look at how when we destroy the block, it spawns the particles in exactly these positions, almost, and they start moving around and colliding with the terrain. They start moving around and interacting with the terrain. We need to offset them a bit on the positive x, the positive z. We need to offset them on the positive x and z by 0 point something. No, positions are not perfect. A little offset they need. And on the y as well, a little offset. They need a slight offset. Here, let's do like const static float offset equals 0.2f. Let's start with that. Plus offset. Let's do that. Like that, and let's see if this offset helps. It was never going to be added. We need a restart. And let's see if the positions are all right. 0.1 offset should be it. Let's do 0.1 because now we're offsetting too much. We're offsetting too much. 0.1. Let's do 0.1. Let's restart it. And let's restart it. No, offset is the same for all of them. Yeah, I'm offsetting all of them, which is exactly what we need. But the exact offset is the question. Yeah, I think this is perfect. Look at it. Positions are perfect. Yeah, this is perfect. The positions are perfect. This is the particle. It follows the player around. That's the particle. And so what now? Oh, wait a minute. Yeah, I think you're right that they need maybe 0.15, probably. But it's fine like that, it's fine. Like this is like trying to make it like exactly. We'll do one final one. So here instead of 5 to 125. This will be the final one. It should be fine, this offset. But we have the positions. That's the most important thing. Now we'll spawn this particle here and scale down. We will spawn it here. Yep. We'll spawn it here. This thing here, we'll spawn it. For each one of these. Yeah, let's do that. Let's actually do that. Let's actually do that. Here, let's commit this. Block breaking. Particle positions. Let's see now. Where do we use them? Here, when we draw a sphere. Instead of drawing a sphere, we'll draw the billboard. We'll draw the billboard. So here, like this. And here we join this. We join this. Perfect. And we delete this. We delete this. And here for position, I need vector 3 position equals particle positions in the index. And here, where is the position for this? Ah, here. Position. Like this. And we need to scale it down. Let's scale it down to 0.2, let's say. Like to 0.2. And now we should not see the big particle, we should see it here. Yo, yo, yes. Look at them. And they should be different. They should be different scale and different They should be different scale and different, what do you call it? And different texture size. But it's very good, man. Yo, it's very good. And the lighting as well. And physics. We're just adding more and more and more. Why is it rotating following the camera? Don't worry about it. Don't worry about it. All of them are squares. All of them are squares. Yeah, all of them are squares. They need to be... Okay, let's make the scale now be random. Let's make the scale be random. Let's make this be the max and 0.1 be the min. Something between these values. Here for the scale. Like Perlin noise? Question mark? Because here Raylib just has integers for random value. Raylib cheat sheet here, random, get random value, they just return integer. They just return integer. They just return integer. We could... Okay, let's... One option is to use Perlin noise. The other option is to use this and like change it up a bit. Float. Here. Noise. Here we can do get random value. We can do between 0 and 10. Between 0 and 10, and we divide by 100. We divide by 100, and here we subtract the noise. And this will do it. What's up, Immortal Dev? They're pulsating. They're pulsating. I think they're fine, man. Chat, is there something wrong with them? They're pulsating. They're just excited. They're just excited. Flawless. Okay, let's create a particle structure because we need to take in a bunch of values. This needs to be done once and forgotten about. How are we going to do this? Yeah, let's make a header file. Particle h pragma once. Here structure particle. We'll do a particle. It will have a position. It will have velocity. Here we need to include Raylib, and it needs scale, or maybe just a random noise value. Like one option is here to just have the noise, and we'll get the scale from the noise. That's one option. Or we can just have the scale here. Doesn't matter. And what else? Texture maybe. Here to do let's do just char. Texture. Let's just do texture like this. And what else? And let's do a constructor. Let's do a constructor. Let's do a constructor. Particle, and which takes a position. A vector 3. It takes in a position. Petsa, what are you going to add next stream? Don't worry about it. I don't know. Chat will decide tomorrow what we do tomorrow. Position. And let's set the position. Here we set position. And for scale. No, we need the CPP as well. Particle CPP, include particle header, and what do? We need to implement it. So here position is just the position like this, and the scale will be the random thing we did, just not all the time. Here the scale like this, like this. And what else do we need? What else do we need? I think that's it probably. Oh, and a texture. Okay, let's give it a texture as well. Texture. Let's give it a texture like this, and it's just the name. Should it be just the name or the actual texture? No, it's like the texture ID. It's the texture ID, that's more appropriate. It's the texture ID. Texture ID. ID. And let's regenerate CMake. Let's regenerate CMake. So what now? This is screaming at me. Why are you screaming? There. Oh, here const char texture ID. Now it's fine, and here I cannot do this because here it's not const, and now it's fine. Sure. And now, when we generate the positions, here we just, okay, this should be particle. It should be particles. Let's include, oh, what did I do? No, let's include actually particles. Let's include particles. And here particle position. Oh, we don't have default constructor. That's fine, we can create one. Here we can just do 0, 0, 0 and like no texture. Oh, but it's const. I will not be able to change it later. Hey, come on, man. I was going to do like particle, and here 0, 0, 0 and nothing. But it needs to not be const. Needs to not be const. Here doesn't need to be const, and here here can be const. Now it's fine. And wait a minute. Yeah, here can be const. Okay, it doesn't need to be const like this. And here vector 3 like this. Any issues? Maybe because of this. Const character, yeah, here it wants const. But then I cannot put it here, I think. Cannot put it here. add crafting next stream. We'll do that next stream. I'm not promising we're doing that next stream. You guys, the first viewers get to vote. So I'll put crafting as an option and people need to vote it. Here, how can I handle this? I'm confused. Okay, we can, what if we delete this and here we do texture ID equals texture ID. Here to be like this and like this. And so how to make it not be like const, like to make a copy, I don't know. Or to just have it be std string. Because I need, oh, no, it's fine, no, it's, I think it should, no, it's fine. No, let's bring the, yeah, it's fine. And no, everything is fine. False alarm. Okay, so now, particles, it's not just the positions, it's actually particles. Here, let's delete this and have here vector3 particle position. And here, this needs to be particle, a new particle, which is the particle position, and we'll use the, what do you call it, the block dirt. We use the dirt texture. And now when we use this here, we need to get the particle. We need to get the particle, and here is the particle position. Right? And here is the what happened? Oh no. Okay, perfect. Let's remove this. Oh, I have caps lock on. I had caps lock on and it broke Vim a bit. Okay, it's fine now. Let's move this particle up, and this is the scale. This will be from the particle scale, like this. And now the particle should be fine. And here, let's get the particle texture. This is particle. We need to move it up a bit. This is the particle texture ID. Perfect. Now we should have particles. Add wither. Can you make YouTube live polls so viewers can vote with future you should add next? And that's for viewers that come early. Even polls are for viewers that come early. Wrong texture. Oh, wrong texture. Yeah, because we don't have a particle yet. And so here we'll do. Here we'll do if particle texture ID is empty to continue. Will not render the particle if it doesn't have a texture. I was 10 minutes late. Don't worry about it. Don't worry. What happened? Let's remove a block. Yo, what happened with the collisions? Okay, now it's fine. Now it's fine. Okay, now if we remove a block, we should get the particles. And they should be with random scale. Yeah, they look to be with random scale. And let's make them to have random regions of the texture. Let's make them have a random region. So let me think about it. We will need, so it's 16 pixels. But here it's 64 pixels resolution. We can pick a value from like, let me think about it. We need a value from 0 to 1, I think. We need a value from 0 to 1 and to multiply it by the texture size, which should be 64. Let me think about it. Let me think about it. Let me think about it. Yeah, I want this to not be the entire texture. I want this to not be the entire texture. Guys, for being able to catch the stream, usually viewers manage to catch it early on and get into the voting by just joining the Discord. Like in the Discord, you get a notification when I'm live. Like here, Twitch. Yeah, pink. You get a pink when I'm live and you'll be the first one there. And here we also have projects. Look at how many projects we have here. Like so many projects. You can put your project there. It's like you can make your own like devlogs in there by creating a post. We need to catch part of the texture. But is it that important? Because we need, we have 40 minutes. Let's prioritize collisions and moving the particles around. Let's prioritize that. That would be much more useful. Let's prioritize that. Yeah, let's prioritize that. Yeah, that would be more. Let's ignore that it's using the whole texture. Let's ignore that because we're low on time. Let's make them move around. Wait, does the scale change at runtime? Like, do they become smaller when we break it? Do they become smaller? They stay the same. They stay the same. They stay the same. And they just have a direction they go towards initially. Yeah, in Showcase project, you can show what you're working on. For the trajectory, we just add gravity to it. We'll give it a direction and add gravity. It's not that deep. We'll just add gravity to it. Yeah, it's fine, it's fine. We need to go through all of them and update them. Okay, so it needs to have a current direction is going towards, I think. Oh, that's just the velocity. That's just the velocity. So yeah, we just need to give it initial velocity direction. And oh, look at how... What direction do they pick? Is it like completely random? Or do the top blocks pick the top side? Does somebody notice like a top particle to pick a different direction than top? Like, are they actually random? Yeah, I think they're actually random directions. Yeah, they're random directions. Yeah, random direction. Yeah, it's fine, it's fine. The velocity direction is outward. Let's just pick a random direction. Let's not overcomplicate it. We'll think about it. Let's just add gravity and collision. Oh, let's do that. Let's do that. And we'll add gravity and collisions. Oh, what's up, Preston? I removed your timeout yesterday. Like, I removed it yesterday. Why is chat so small? Don't worry about it. Let's add gravity and collisions. Let's add gravity and collisions. Let's do that. Let's do that. Right? Let's do that. Gravity and collisions. And let's do a commit. Let's do a commit here. Particles have random scale and they have their own structure. They have their own structure. And let's actually... I'll just add gravity to them, it's fine. I'll just add gravity to them. And let's update the stream thumbnail so that viewers have the right expectations. Let's update the like this, and done. We're using the proper one. And I lost chat. Where is chat? Here is chat. Okay. Now we have particles. Let's add gravity to them. Let's add gravity to the particles. And let's make them collide. Let's make them collide. Let's make them collide. So we need to go to where the particle is, and we need to add update, void update, which is called every frame. And let's implement it here. Let's implement it, particle, like this, update. So what do we do now? We need to update the position. Position x equals velocity x times plus equals, I think it was plus equals. And here times we need delta time. Float delta time equals get frame time, like this, and here by delta time. And we paste this 2 times, and this is the y and the z. Perfect. And we need gravity, const float static gravity equals, I'll do it the same like for the player, which comes from the entity. Where is the entity? The entity CPP. Entity CPP. Where is the gravity? Gravity. Oh, it's in the player CPP. Gravity here. And where is the particle? Here. Like this. And so we will update the velocity with the gravity. And now all of them should fall down. All of the particles, I think. Yeah. And we need to call the update for all of them. We need to call the update for all of them. Yeah, we iterate over all of the particles. Guys, don't look at the view count. Don't worry about it. Here, where's the particles? Yeah, this array, particles. And here in the while loop, we'll update them, all of them. Let's just do it here. And here we iterate over all of the particles. We need to call particle update, I think. Like this, we need update. Yeah, now they should fall down. But they will not have collisions. Like, I'll try to add collisions, but they don't have them now. And it should be very simple to add collisions. Should be very simple. Okay, now it loaded. Okay, now if we destroy this, particle should fall down. Where are they? Oh, they went up. They went up. Bro, why do they go up? Why do they go up? And why do they go so fast? Oh. Wait a minute. The y minus gravity frame time. Yeah, this is the delta time. Right? Am I missing something? Like, I could like easily invert it, but it was the same for the player. Where is the entity? Here. Update position. It's, yeah, plus velocity, frame time, yeah. And where is the player? And the player update position, sure. And here we handle gravity, yeah. Oh, minus? Yeah, minus gravity. Get frame time. Particles. Yeah, minus gravity. So, what's the issue? What's the issue? Yeah, I can easily do like plus equals gravity, but I'm not sure why it goes in the opposite direction. Yeah, this should decrease the position. Should decrease it, right? Yeah, it should decrease it. Hello, what's up, guys? Because velocity not initialized. Oh, yeah, it starts from a very big number. You're a genius. Yo, gaming, thank you, man. Like, bro, gaming. Thank you, man. You're a genius. Yeah. You're a genius, man. Velocity. Let's initialize it. Velocity. With just zeros. Let's start it with zeros. Like this. Now it should work. Okay. And now it should fall down. Yeah, oh, yo. Yo, look. Bro. Yo. They fall down. Yo. And now we need to make them collide. Yo. We need to make them collide. Yo. Everything is dirt particles. We need to make them collide. Yo. That's very cool. Yo. Okay, let's make them collide. Handle collision. Let's handle collisions. Player. Here, handle physics. Where do we do them? Update. Here, after update positions. And where do we call this? Oh, doesn't matter. Here, handle collisions, terrain collisions. We need to handle terrain collisions. Let's do for the particles the same function. But we need to make it different. Because the particle just needs a single point. We don't need to do like a whole collision box, I think. Question mark. Void handle terrain collision. Let's do this. And where should we put this? In particle. Like this. And here particle. Like this. And let's copy from the entity because we need to optimize it a bit. Just to make less calculations. Less calculations. We don't need a boolean. Here we don't need this. Do we have like a result? Yeah, let's remove it. And we need position details. We don't need this thing. Do we? Yeah, we need boolean if we're colliding at a certain point. Yeah, we need to check, because in the update, if we're colliding on the bottom, wait, no, we can just do a single boolean if we're just colliding. And just to stop the particle, let's see. What happens when it hits here? Does it slide down? Like, does it slide down when it hits? Yeah, it slides down. Damn. Yeah, when it collides. Let me think about it. So here, for the player, how did we do it with the player? With the player, he just cannot... I think it's fine. I think it's fine. We just need... Yeah. Okay, it's fine. It's fine. We just need one. If it's colliding bottom, to stop it. Yeah, we just need if it's colliding bottom. Let's just do this. Let's go back to the particle. Here. And let's do a boolean. What was it called? Collided bottom. If it collided to the bottom. And here we need the block. I should abstract this away. We need the world. We need, what else do we need? We don't need, if it's collided east, west, top, we don't need this. We don't need south, north, we don't need this. Here the issue is we don't have a collision box. Because I wanted to use a single point to simplify it. I wanted to use a single point. So that we don't need to do so many calculations for the particle collision. Collision box shape. Collision box. Yeah, this is the size. Yeah, this is the points around the entity. But for the particle, we can just do one point. We can still do multiple points. We can start with multiple points. It doesn't matter. And we can still also just... We can still also use a collision box, actually. Okay, let's start with the collision box and we'll think about it. Let's have it have a collision box. Box config. Collision box. Let's have... because I wanted this to be just a single point, to not have a... Yeah, it doesn't need a collision box. So it doesn't have a size, I think? Question mark. It doesn't have a size. What do we break when we remove it? Here, the entity minimum and maximum. If we change it to a point instead of a collision box, is it fine? Like, can we do just a single point? Because it will be more efficient if it's a single point for the collisions. Do not have... Oh, can we enable like hitboxes? Or like, what was it? Like here, if we spawn the bolt... Look at it. This is a collision box. And the player has this same thing as well. And for the particles, I wanted the particles to be simpler. To not be a full entity, to be something simpler. Just one point to be. I think we can... Yeah, we can do it. We can do it with a single point. And here, we'll just check one point. For collisions, 1 point. And here, it doesn't have a minimum and maximum, I think. Yeah, it's fine. It's fine. Yeah, it's fine. And here, we just need to check a single point. The particle position. Yeah, here. So if the position is less than the block... Yeah, this is when we have collision. So if the position if the position like this, in here the position as well. Position. So if the position is inside of the collision box of the entity of the block, if it's inside of it, we need to move it a bit. We need now collision resolution. We need collision resolution here. What do I need to import? Like, what was it? Like, was it algorithm? Question mark? Oh no, it's just, it's an error for the function. The function here complains. So here the overlap. Let's just do the point. Let's just do the point. Position. Position. And here the position. Here the position. The position. And here how much we move it. So we simplify to be a single point, which actually, I don't think this is improving performance. We still do the same calculations. We're still doing the same calculations. Like, I don't think we're doing that much of an improvement. And so for the particle, when we update it, after we move it, let's do handle collisions. Handle terrain collisions. I think particles collide with themselves as well. Probably. They collide with themselves. Handle collisions. And so what now? Is this it? Is this it? Why do you play on 1.21.4, not newer version? That's what I started with. These streams. Oh no, we need to handle it. We need to handle it. We need to. Yeah, we need to handle it when we are colliding to the bottom here. If collided bottom here like this. If we are not on the ground, to have the gravity. If we are not on the ground. And let's test it out. Now, do they have gravity? Or maybe they fall too fast. Or the movement up is oh, wait. Let's go under here. Let's see what... collided bottom. Handle terrain collision. Oh, wait a minute. In here, starting player... Oh, no, it's fine. Yeah, it's fine. So we check the position where the particle is. We get the block at that position. We can offset it to be a little bit downward. To be a little bit down. So like -1 on the Y. Like -0.1 on the Y. Which shouldn't make that much of a difference. They're not stopping at all. Particles don't stop at all. So let me think about it. Yeah, we get the block. Sure. And if it's a block mesh, if the mesh has parent block, sure, and if it has collision boxes, sure, this part is all right. I don't have issues with it. We could simplify it. We could create it to be an entity. Yeah, let's make it an entity, and it shouldn't have performance issues. We'll do optimizations later. Yeah, let's make it entity and have a collision box. That would be best for the little time we have. Let's temporarily commit this particle. particle collisions drafts. Temporarily commit this, and let's make the particle be an entity. Public entity. We don't need position and velocity. Entity. We don't need position and velocity. We don't need to... do we? No, we don't need this. And we don't need this. And update here. Yeah, we handle terrain. And here we update position. Here we update position. We update position. And what else? And we don't need this function. Right? We don't need this function. We don't need this. We don't need this, and what else? What else? We need to initialize the collision box. Here, the position, I think we need to do like, what does the entity have? Entity, it has just this. Okay, so we need to set positions ourselves. Position equals position. Like this. Like this. And here, texture ID. Texture ID equals texture ID. And velocity. Velocity equals velocity. Equals this. Zeros. And we remove this. That's it. That's it. And we need to set the collision box. Collision box. We need to set it to be this is from 0 to 16. This is in pixels. So like 1 pixel on each axis. Right? Right? Let's see what happens. Let's restart it. Okay, fine. This looks good. And so what now? And now let's test it. Are you ready, guys? Do we have collisions? Bro, what did I miss? Is it like I set it to be entity, right? Let's look in the player for like inspiration. The grass is floating when you break the block. Don't worry about it. That's for some other time to figure out. So the player, we update the player by updating the position. And here we handle collision, sure. We process process movement here. Yeah, we have direction, sure. We don't care about directions right now. And if we have if we are colliding with the bottom, we handle ground physics. Else we handle air physics. And our air physics is just like the gravity. Is the gravity. So here, player here. Yeah, first we process this. First we process movement and then we update. Okay, maybe the ordering is bad. So let's go to the particle. Guys, we live, right? Like the chat froze. We're live, right? Here. Update. Yeah, it should be here. Should be here. Yeah, first we update the velocity. Then we update position, then we handle terrain collision. Sure, and let's test it. And let's see what happens. Bro. No, are we calling this function? Maybe we're not calling it. No, we should be calling it because we have gravity, obviously. Let's else. Let's do an else and do a int like I equals 1 and like put a debug here. Put a debug here to see if we get here in this else statement. To see if at some point they at all collide with the bottom. No, we don't get a breakpoint. We don't get a breakpoint. We don't get a breakpoint. Collision box. Yeah, this should be the size, collision box size. This will be... Oh, I'm dumb. I'm very dumb. Where's the... Yeah, I didn't set the collision box right. Yeah. Collision box from 2. The 2 I need to change. This to be 1, 1, 1. Yeah, guys, I'm just dumb. We need to restart this a couple of times. And now let's test it. It has collision box, right? From is 0 and 2 is 1. Okay, let's increase it then. Let's increase the collision box. Maybe it's too small. Let's increase it to like 16. 16 by 16 by 16. And let's see what happens. Yeah, I increased it. Yeah, we're using the same collision code like the player. The player is an entity. And we've set the particles to be entities as well. We've set them to be entities as well. This is the collision box, right? Yeah, this is the collision box. And I'm setting... Oh, let's set the from to be 0, just in case. Maybe the initialization is wrong. The from and to. Maybe it initializes wrong. Hotbar sometimes breaks. Oh, yo. But I need to decrease the collision box. And here I need to... Yeah, I need to decrease the collision box. Yo. I need to decrease the collision box. Do you draw the textures yourself? What do you mean? Raylib draws them. No, I haven't made the textures. It's like... what do you call it? Fateful. It's Fateful, the resource pack. Yeah, let's test it now. Bro. They're colliding. But how much? Yeah, there they are. Some of them fall. Some of them fall. They move too fast and some of them fall. But some of them collide. Some of them collide. Let's make the gravity be less. Like here, let's make it be like 15. They fall because the collision box is already touching the bottom block. Ah. Oh, you're right. I did a... Yeah. Yeah, you're right. Oh, no. Oh, yes. Let me think about it. No. Let's see if we changing the speed makes a difference. Let's see if changing. I slowed down the gravity. Whatever happens will make them move at different directions, like to pick a random velocity at start. We'll do that as well. Yo. Let's see. Some of them fall again. Maybe it's the ones at the... Yeah, the ones at the top maybe become too fast. I don't know. I'm not sure. But it's fine. It's fine. Let's make them pick a random velocity. In the start. Here, the velocity. Some particles escape the matrix. Let's pick a random velocity. So, how should we pick it? So, how should we do it? The velocity. We need just a random direction. On the side, they most likely will also collide. They will just not stop. And they will just continue to go down. They should slide down. I need... I need a random direction. I need a random direction. And how should I generate it? I could do the same like in the handling the camera. Temporarily. Just temporarily. Here, this cosine and sine. Here, yeah, here. Here. We'll do vector 3 front, let's call it. And here, let's do float yo equals like a random number, and this is the pitch. And what should the random numbers be from? From 0 to 360 maybe? Question mark. Get random value from 0 to 90 to 180. Let's do 360, doesn't matter. And here the same. And here and the velocity will be vector 3 normalize the front, and we maybe to multiply it by some speed, question mark. Let's test it like this. Now they should have random directions they go towards. You fix redstone? What do you mean? Let's see if the particles go in random directions. Yo! They need higher speed. And what's happening, man? They need... let's multiply by... let's multiply by like 5. And... when it collides the bottom, else if it's colliding, velocity to be 0 when has collided bottom. Velocity to be 0. And let's test it out. Let's see if they... Bro, particles. Particles. Yo. Particle. Bro. Yeah, they're a little bit explosive. They're a little bit explosive. Yo. Yeah. Let's use the particle texture. Okay. Let's lock in. We have a few more minutes. We don't have any minutes, but let's lock in. I just want to do something more. Particles going random directions. Let's lower the speed, the initial speed, to be 1.5. And also when we create them, where do we create them? When we break a block, particle. Particle. Here we need, what do we need? We need the mesh of the block. And we usually get that. Where do we get it? I want to copy code. Where did we get the mesh of the block? Where did we do that before? We did it for last, what was it? Yeah, this thing. Get last parent, this thing. Here. Let me think about it. I'm trying to get the particle texture to be different for every block. That's what I'm trying to do. Here I don't want this. Here this, and I need the ID. This is hover. We need the block hover. ID question mark. Are we using this anywhere? Yeah, I think we're using it. Yeah, we're even updating it. Sure. Yeah, we are getting the JSON file. We're getting the JSON file for the mesh. And now we need, for that file, we need the block model. We need the texture ID. We need the texture ID. Const char texture ID equals world get. Can we get? What do we need? I think I've done this before when we generate the mesh, right? When we generate the mesh. Where was it? Here. And the JSON, yeah, here, this thing. So I don't have function for that. I need to make one. I need access to this. Let's make one. Static. What does it return? It returns const block model. Get block model. And here const char key this, and here we return this like this, and here this should be the mesh pool, and here this is the key. Sure. And now This is so we can get the particle texture. Get block. This is in the cube mesh pool. Pool, get block model. And here I want the textures particle, right? I want the particle texture. Block model, textures, sure. So let's do add. Let's do add. Let's do add. And here, this. Like this should. Let's get reference to it. Block cube mesh pool block model. No, actually, we can do it differently. Get mesh texture. We can do differently. I want the particle texture. Static const jar get model or get mesh texture or get like model, get block model texture const char block model key and const char texture ID like this. And here we do block model key add no textures add texture ID like this. And what does it return? It returns string. It returns string, so we can do std string. Right? Can do std string. String like this. And so now we'll get the particle texture. Here get block model texture. This is for the JSON model file name. What does this return? This returns string. And here we do JSON model file name like this, and we need the particle. Bro, all of this just to change the texture. And here we do texture ID like this. And here this needs to be std string like this. And this C string like this. Okay. Let's see if now we can get different particles for different blocks. What's your problem? Must return a value. This thing. Get block model. We don't need this. Now we should get a different texture for destroying different block, if it manages to run. Okay, let's see. Oh, it has the Minecraft thing. It has the Minecraft namespace. We need to remove it, sadly. How did we remove it? I've done this before. We can copy it. Minecraft. Yeah, this thing, the namespace. If it finds it, we erase it. If it finds it, we erase it. It doesn't matter, it doesn't look pretty, it's fine. It's fine. If you write your source by watching, don't worry about it. That's a waste of time. Like it will be like it's doable for sure, but that time can be better spent at many other things. It's not worth it. Totally not worth it. Let's see now. Which is it now? Which key? Oh, the key is wrong. The key is wrong. So what do we do? This is the namespace. We search for it if we can. If we find it, we erase it. Let me think about it. Yeah, we need to do a breakpoint here. We need to do a breakpoint. We need to do a breakpoint of the texture ID and see what's up. Petsa, when you finish your Minecraft clone, what other projects are you going to do? My own voxel game I want to do. Texture ID. We need the other one. We need to start from here. Right? We need to start from here and do debug. Same thing? No, that's like calling Hytale and Minecraft the same. Maybe wrong in initialization string. We'll see what's up. We'll see what's up. When you make your voxel engine, can you make a FPS multiplayer game using C++ and Raylib? You do it yourself. Why should I steal your idea? What's up here? Okay, when we break block, what do we get here? Particle position. JSON model file name. It's the grass block. Texture ID is the Minecraft block dirt. Namespace Minecraft. Position 0. We erase it from this. We erase it. And now it should be namespace position, namespace length. Now it should be proper, right? What happened? Yeah, we changed the texture ID and here, okay, let's go inside when creating particle. Texture ID is block dirt, perfect. Perfect. It's block dirt. Texture ID is block dirt. Yeah, it's fine. Yeah, it's fine. So why did I get the error? Wrong texture and grass block. I'm confused. Here, it should be the dirt one. Should be the dirt. Like what we're trying to do now is the particle had the same texture for every block. It had the same texture, just the dirt block. Grass block. Where are we getting this from? From here. Get texture coordinates. Wait a minute, why here? Texture ID is... Yeah, let's look at the grass block. Look at the grass block. Yeah, particle is the dirt. Particle dirt. So where is the grass block thing coming from? Where is the grass block thing coming from? Here. Texture ID. Get block model texture from particle. Here. Yeah, let's put breakpoint. It's fine that we're breaking grass block. That's completely fine. That's completely fine. Here, texture ID is block dirt. Perfect. It's the dirt texture. And here we erase this. And here in the particle, texture ID is block dirt. It's perfect. It doesn't have mistakes. Absolutely zero mistakes. Oh, I'm probably setting it somewhere else. Probably. Let's look at the... when we draw the billboard here. Oh, wait a minute. This thing, yeah, I'm using the particle texture ID, right? Let me look at all of its references. Maybe we're changing it somewhere again. Probably. Texture of, what are these references, man? Here, here, here. So it should be fine. Particle. And only here we create the particle. Only here we create it. Yeah, it should have. Oh, wait a minute. We're creating it multiple times. Wait a minute. Wait. We don't need to do this multiple times. No. Yeah, let's not do this multiple times. We need... Yeah, to do... Oh, yeah, I get it. Let's do this once. Now this should be fine. Now this should work. How many Minecraft clones do you have? Like 5, 6? I don't know. I lost count. But they are all different work. Yeah, this is tone for some reason. For this particle. Yeah, here we're getting to search, it's searching for stone. Texture coordinates. I cannot look up the... Okay, let's do here breakpoint. Maybe wrong pointer. What do you mean? Where? Here, what's the particle like? F11. F11, the key is block dirt. It's perfect. It's block dirt. It's perfect. Yeah, it's perfect. Continue. This is the next one. Can I look at this thing? All of them. Can I look at all of them? Yeah, all of them are block dirt. All of them. All of them are block dirt. So there's no issue. All of them are block dirt. So why do they change? We don't... we don't remove anything else. They're perfect. They're perfect, but when I continue it, we get a wrong texture here. That's very weird. If we didn't get the error, we would have already been done with the feature we're trying to do now. We would have already been done. But we get random problems. Text coordinate, particle, texture. And here texture is, if it's empty, we continue. But here it gets random. It gets very weird texture IDs there. Very weird texture IDs. And we do not change them afterwards. They should stay the same. They should stay the same. Yeah, it starts searching for the Minecraft grass block. And the particles. Particle positions. Undefined. Remove if block if you can throw and check behavior. Let me think about it. Let me think about it. Main particle. We get texture coordinates of this thing. And sometimes this texture ID is completely wrong. But when we checked this array, all of the particles looked right. And the problem is I cannot see where this mess up happens. Where exactly does it? Maybe. And here. Oh, wait a minute. Maybe because. Yeah. Let's go back to the particle. Let's change this to be std string. Include string. Let's do it like this. What's your issue? And here should be fine. Yeah, most likely it's being changed afterwards and it's affecting the const char reference, maybe question mark. But it's a const char, it's like const, like not member of std. That's why I include string. We'll see, we'll see. Okay. It was that the issue. We were taking like a reference. We were taking a reference. The reference itself was being changed. Doesn't matter. Let's see now what happened. This was for the lock. This was for the lock. Does the lock have a particle? Like the spruce lock JSON. Does it have a particle? Oh, it doesn't here. And I'm searching inside of here. I'm searching inside of here. But it's probably in the parent. It's probably in the parent, which is cube column. Cube column. And it has particle the side. Yeah, it comes from here, the particle. And I need to go back in the references for the log itself. That's a bit of a bummer. That's a bit of a bummer. But stone should work probably. Oh, stone is the same as well. It's a bit more complicated. For stone, I would need to go like... Yeah, here stone JSON. Here. It just has the texture all. And it uses cube all. Cube all JSON. Here. It has particle here. Okay. We can... I think we can do this. Here when we get the texture. Yeah, okay. I have an idea. We can do it. Hopefully we don't do this to 4 hours. Hopefully. Like the limit was 3 hours. Here, when we get the get block model texture here, we need to go over the parents. Yeah, the parents. Need to go over all of them. Right? Bro. And like this when we're getting the texture. So this is the model name. The model name. And we have the block model. I want to do a stack. We don't need one. And what else? We iterate over them. Yeah, let's do... Okay, let's do the stack. Doesn't matter. Doesn't matter. Like we're desperate here. So here we have the models. We need to iterate over them. We need to go back to the first parent. We need to go back to the first parent. And what do we need to do? JSON is from resource packs. And we need to, what do we need to do? We need, when we're getting the texture, where is it? Here, this thing. We need this thing. Yeah, we even to go even here, I think. Texture ID. Sure. Sure. We need all of this. And we need to remove the namespace. And that should be it, right? Yeah, that should be it. And so let's copy it here. Let's copy it here. We are going over all of the parents. Here the texture is, what's the texture? No, what are we doing here? Ah, we are looking for particle. We're looking for, yeah, we're looking for this thing. Let's call it like texture key. Texture key. And here this is texture key. And we iterate over the parents. Sure. Like this. And we remove namespace. And we return texture ID like this. And when we call this function in main, we don't need to remove the namespace. We don't need to remove it. And let's see what's up. Let's see what's up. Is this still working? It's working. What about this? Yo, bro. Oh, the leaves. Oh, they're not getting colored. The leaves are not getting colored. But the log is fine. And stone should be working as well. Yeah, stone is working as well. Stone is working as well. And grass is working as well. Bro. And what about grass? Yeah. It cannot find it for foliage. What's for foliage? Maybe it's generic one. Bro, we cannot go in slow motion. What was it called? Tick rate 20. For grass, I don't know from where they get it. Cross, JSON, cross. Particle is the cross itself. Yeah, and so for short grass, yeah, it's using the cross, the short grass, right? Yeah. And it's using tinted cross. Tinted cross It's using tinted cross. And here we have particle is the cross itself. So what's up, it should work, right? Let me search short grass. Oh, it's using just grass. Short grass. Okay, okay. It was using the wrong JSON. It was using the wrong JSON. It was using the wrong JSON. Bro, we have the grass. But it's not colored. It's not colored. It doesn't have the coloring. What about the flower? We have the flower. Look at the flower, man. We need a different one. We cannot. Water doesn't have an outline for us to pick. Yeah, but this is fine. This is fine. What about piston and lever? This snow. What about fire? It will probably break the game. This obsidian. Okay, piston. Particle. Piston. Piston. Piston is the template piston. And template piston. Particle is side. Yeah, I'm probably again using... again, I probably need to change up. Grass blocks are bugged in Minecraft, produce dirt particles instead of grass. No, it's fine, it's not bugged. Like, this is by design. It's by design like this. They have in the JSON file, they use this. They probably avoid the grass block texture because you need to change it up a lot. You need to change it up a lot. Like here with this, we need to color it. And when they use the grass, they need to color it as well. But exactly the overlay. Now we can decrease the particles. We can decrease them. You know. Oh, this was the snow. Yeah, some blocks need to be fixed up. Some blocks. Some blocks need fixing up. Guys, here's a link. Here's a link to my Discord to get notified when I'm live. That's a link to the Discord to notified when I'm live. And there you can see a channel where you can post your projects like a devlog. Because I've talked to people in my chat to make videos about their projects, just like I do, but they say that either it's too saturated or and they don't do it. And so I tell them at least make a post in my Discord channel. Nobody will see it, but if you want people to see it, put a tag to be reviewed on stream, and I'll review your project on stream, and I'll make probably a video about it. We'll see, but for sure on stream. At some point I'll go over the projects. But you can also join there to get notified when I'm live. And so let's do a summary and we'll end it because my duration was like 3 hours. I wanted 3 hours and we're like at 3.5. So let's do a summary. So today chat, like previous stream we did the caves. In this stream chat decided, the viewers that joined first, they decided that we should focus on particles. And we added particles just for block breaking. And they use the texture of the block. Like this one is the dirt and this one is the stone. And here for the grass, they're using the grass, but I need to color it. And also I need to make them smaller, like to use part of the texture, not the whole texture. To not use the whole texture. And here this uses the spruce log and this uses the leaf, but they need to be colored. They need to be colored. And yeah, we managed to do the particles. We don't have them for like the torch. We don't have all the particles, but we're getting there. Like we're getting there. We're getting there. So anything else that we did today? I think that's it. Yeah, so bye guys, like thank you for being here, thank you for watching, and that's it. That's it. Yeah, bye guys. I'll make a screenshot for the thumbnail. Yeah, bye guys.